Alright, so this time what we're going to do is we're going to do a linear algebra problem. Basically this is usually the first topic that happens in most linear algebra classes, whether it's engineers or the regular strain of classes. So what it is solving linear systems. This is a 2 by 2 linear system. This is because I have two equations and I have two unknowns, x1 and x2. To solve this immediately, by now you should know we create the augmented matrix, which is 1, 1 equals 4 and 1 minus 1 equals 3. Now that I have my augmented matrix, I use Gaussian elimination to go to row echelon form. How do we do this? It's basically, I have to steal another color, but what I have to do is, at first, if you're just training yourself, you follow Gauss's mantra. I don't know if it was Gauss first, but my mantra called Gauss's mantra is you want to get a leading one in the top left hand corner and then eliminate all non-zero values below it. So this one has to stay, which I've already given myself in the question, and then that one has to be eliminated. So Gaussian elimination, what we're really doing is eliminating variable x1 from the equation, this equation. To do that, what I'm going to do is row 2 is going to be replaced by row 2 minus row 1. Once I do that action, especially when you're on an exam or in a time crunch scenario of homework, I'm doing it and it's due tomorrow morning, well, so I better hurry up. The fastest way to do this is to copy out the row I'm not changing. Now I have to turn the thinky brain on and do the calculations of the row reduction. I still like to use my fingers, especially when I have the board, so I can keep everything in line and get it right. This one's not so bad. All I'm doing is subtracting. So 1 minus 1 is 0. Minus 1 is negative 2. And 3 minus 4 is negative 1. I can already see what the solution is right now, or part of it. Anyways, what that says is negative 1/2 x2 equals negative 1. Or x2 is 1/2. What I really like to do, and so in the video I will show you, I like to get leading ones. So I'm going to do one more move. Row 2 goes to negative 1/2 row 2. And that will give me this 1, 1, 4. And now I'm changing this. I'm dividing everything by 1/2, negative 1/2. And so I get this. Now what we're going to do is move it to the top of the board and then show how to, this is definitely REF. So row echelon form, this is what we're looking for. Again, quickly, what are the three axioms to get into REF? The three things I need to get into REF are all zero rows go to the below any non-zero rows. I don't have any zero rows, so that's good. That axiom is checked off. Axiom 2 is in any rows where I have leading entries. I have two leading entries. These two are my leading entries now of the rows. I have zeros below them where I can get zeros. So this one is a leading entry and it has a zero below. This is the leading entry and I have no more, so we're good to go. And then the third axiom, which is weird, is essentially the third rule is you need to have the leading entry in the lower row has to be further to the right than the leading entry in the upper row. So this is exactly what we have. So this is definitely REF. So now that we have it back up at the top here and I'm in REF, you need to practice remembering that this was Gauss's easy way to eliminate all the variables and the algebra and stuff that was going on in that system, and this is only 2 by 2. You basically, what you should do is, these are all equations. It doesn't hurt rewriting out what it says. This literally says now I have a new simpler system which is equivalent to the first system, which says this, and now it says x2 is equal to 1/2. So right away what it's actually telling me is the part of the solution is the second guy has to be 1/2. What we can also notice is, and what you need to know is, in the other two videos there's the other two cases. You can only have one solution, no solutions, or infinitely many. In this case we got infinitely many, or sorry, a unique solution. And how I know that is because in REF I had two unknowns originally and I got two leading entries. So that means that I will have a unique solution to this system. The unique solution we already have partly. We know that the x2 coordinate or the y coordinate will be a 1/2. So we're in REF. I've noticed that I have a unique solution because I have x1 and x2 are my two unknowns, and I have two leading entries or leading ones in my REF. So I definitely have a unique solution. Now explicitly to solve it, we mean find the general solution. The general solution is either going to be the unique solution, you say no solution, or the infinitely many solutions. But when we say solve, you actually have to tell me what it is. So in this, classically, what I like to do is at first especially get to REF and then back substitute, we call it, to find all of the values of them. In this case, I only have to find 2 and I already have one. x2 is 1/2. To find x1, we now solve for x1 in this equation. We see that it's 4 minus x2, and we know what x2 is, it's 1/2, so that's 4 minus 1/2, and so x1 is equal to, I'm going to multiply by 2 to get a common denominator, by 1/2, so I have 8 minus 1 is 7/2. So the general solution is given by x1 equals 7/2 and x2 is equal to 1/2. This is the general solution to this system of equations.